Hello everyone, I'm Alina Michael, currently pursuing my MCA from Marian College, Kuttikkanam, Autonomous. Today I'm here to present an interesting and somewhat unique applications of graph theory in the field of software development and project management, especially focusing on software dependency graph. Before we begin, I would like to take this opportunity to thank Dr. Mendes Jacob, the Director of the PG Department of Computer Application at Marian College, for his invaluable guidance and support throughout this process. So without any further delay, let's get started. Now, let's move on to the next slide. Software dependency graphs are a graphical representation of the relationship and dependencies between various components in a software system. Each node in the graph represents a module, library, or component, while the edge represents dependencies such as module A dependent on module B to function properly. This visualization allows us to see how the components interact and depend on one another, providing a clear overview of the system's architecture. It serves as a foundation for analyzing the system structure and identifying potential areas of improvement. Dependency graphs are essential tools for software project management as they provide insight into the overall structure of a system. They allow teams to visualize interaction between components, which is crucial for identifying critical modules with high dependencies that might pose risk. These graphs also help uncover potential bottlenecks, enabling teams to plan development and testing phases more effectively. Additionally, dependency graph optimize timelines by showing which components can be worked on independently, leading to better resource allocation and project efficiency. There are several practical applications of dependency graph in software project management. Firstly, they allow teams to visualize and understand the interdependencies within the system. This makes it easier to identify crucial nodes or single points of failure that could disrupt the project. Secondly, dependency graphs are instrumental in deleting cycles, which occurs when two or more commands are mutually dependent. Such cycle can cause runtime errors or build failures. Finally, dependency graphs help allocate resources by identifying independent modules that can be worked on simultaneously, ensuring that projects are completed efficiently and on time. To illustrate the application of dependency graph, let's take an example of an e-commerce platform with a microservice-based architecture. This platform has services like payment processing, user management, and inventory management, all of which are highly interconnected. These dependencies often lead to challenges such as scalability issues and service failures. By creating a dependency graph, engineers can identify critical services such as the payment gateway, which has many dependencies and requires careful handling. The graph also helps resolve cyclic dependencies between services and decoupled interaction where necessary, resulting in a more scalable and resilient system. Dependency graph offers several advantages in software development. They enable efficient planning by helping teams prioritize tasks and allocate resources wisely. This graph also allows for the early identification of risk, reducing the chance of failure during development or deployment. By addressing bottleneck in the dependency structure, teams can improve the system scalability and robustness. Additionally, dependency graphs make debugging faster and more effective by providing a clear view of how issues propagate within the system. In conclusion, software dependency graphs are a powerful application of graph theory that bring clarity and efficiency to software project management. They provide a clear visualization of complex system architecture, enable effective risk management, and streamline the development process. By leveraging dependency graph, Organization can ensure that their software systems are robust, scalable, and easy to maintain. This approach is particularly valuable in modern software engineering, where complexity and interdependence are constantly increasing.